Okay, I'm going to go over quiz 7. The first problem reads, a hopper contains seeds for reseeding a lawn. It is shaped as a square pyramid with the point facing down, with the seeds pouring out of the bottom. The volume of the pyramid is V equals 1/3 BH, where B is the base area and H is the height. For this hopper, the base area of the pyramid is 3 times the height squared. So B equals 3h squared. Find the equation that relates the rate at which seeds are being poured out of the hopper and the rate at which the height of the remaining seeds is dropping. That tells us that what we want to find for this problem is a relationship between dV dt, the change in volume with respect to time, and dH dt, the change in height with respect to time. Now, they've given us some added information about B and H. We know that B is equal to 3h squared. So then we can express this volume equation as entirely in terms of H. This means that V equals 1/3 3h squared for B, H, which is just equal to H cubed. Okay, now we want dV dt and dH dt. So in order to find those, we're going to have to differentiate with respect to time. Now, remember, V is not just a variable, this is a function of time, right? V is changing with respect to time, as is H. So when we differentiate, we'll get dV dt, the derivative of V with respect to t, is 3h squared times the derivative of H with respect to t. So that is our answer. For the second problem, it says, if the seeds leave the container at a rate of 24 centimeters cubed per second, how fast is the height of the remaining seeds dropping when the height is 2 centimeters? So they tell us right off the bat that the change in volume with respect to time is negative 24. Notice it's negative 24 because they say the seeds leave the container at a rate of 24 centimeters cubed per second, a change in volume every per second. So they also tell us that the height is going to be 2 centimeters. And what we want to find, they ask for how fast is the height of the remaining seeds dropping. That means we want the change in height with respect to time. Now, we have this relationship that we've already worked out. So we know that dV dt is equal to 3h squared dH dt. Now we just need to plug in some numbers and solve for dH dt. So that tells us that negative 24 is equal to 3 times 2 squared times dH dt. So then dH dt is, this is 12, so negative 24 divided by 12 is negative 2 centimeters per second. Okay, the next problem asks for the linearization for the volume as a function of height around the point h equals 2 centimeters. Use this to estimate the volume at height 1.99 centimeters. Okay, the equation for the linearization, that's just the tangent line, L of h is equal to V h naught plus V prime h naught h minus h naught. Okay, now notice our specific case is h naught is equal to 2. Now, remember we know that V of h is equal to h cubed, so that means that V of 2 is 8. We then also know that V prime of h, the derivative of V with respect to h, notice, because we're thinking of V as a function of h, so we want the derivative, or that's the slope of that function, and that's the change in volume with respect to h. So that is just the derivative of this function, which is 3h squared. And then V prime of 2, well, that's going to be 3 times 2 squared, which is just 12. So now we need to plug in. We know then that L of h for our point is V of 2 plus V prime of 2 times h minus 2. Now our values tell us then that L of h is 8 plus 12 times h minus 2. I could simplify this further, but I don't have to. That's fine for the linearization. Now I want to use it to estimate what the volume is at 1.99 centimeters for height. So this tells us that we think it's going to be 8 plus 12 times 1.99 minus 2, which is just equal to 8 plus 12 times negative 0.01, which is 8 minus 0.12, or 7.88. So our estimation is 7.88, and our linearization for the volume as a function of height around the point h equals 2 centimeters is L of h equals 8 plus 12 h minus 2. Now they say if the height is measured within 0.5% relative error, what is the approximate relative error for the volume? So they tell us that the relative error for height is less than or equal to 0.5%. So remember, relative error is dh over h, so that's 0.5%. And we want to find the relative error for the volume, which is dV over V. Now, luckily we know some stuff. We know if we take the differential for dV with respect to h, then we're going to get dV is equal to 3h squared dh. We also know that V is equal to h cubed. So then dV over V is 3h squared dh over h cubed. Well, that works out to be 3dh over h. Notice we know what the relative error for the height is. It's 0.5%. So this is just 3 times 0.5%, or 1.5%. And that's our answer.